Hello, can you all hear me? Yeah? Can you put your hand up if you're completely incapable of hearing anything I'm saying? That guy can't. I'm so sorry. It might need to move a bit closer. Is everyone having a nice time so far? Doesn't sound like it. I said, is everyone having a nice time so far? That's more like it. That's more like it. That's good. That's good. Right. So, as you can see from this slide, I have fooled you all, and I'm now going to give you an impromptu lecture on Greek theatre and the history thereof. No, I'm actually going to talk about functional programming. I hope that's what you've all come in for, because that's what you're getting. If anyone's interested, a little bit about me, I started doing computing on stuff like this. This is a ZX Spectrum. This is one of the coolest computers that ever existed because it's the one that I started on. It had 48K of memory, and it had 15 colors. Just 15. Strictly speaking, it had 8 and a dark version of each, but one of them was black, so 15. And it was the best thing in the entire world. What I'm trying to say is, I really have been doing this an awfully long time at this point. I'll carry on doing it as well for as long as it continues to be fun, which it has been thus far. I am from a town called Telford in the UK. Has anybody heard of Telford? No special reason you should. It's a little town in the middle of nowhere, frankly. We have a bridge. Hello. It's a very nice bridge. It's a UNESCO World Heritage Site bridge, which means that my wife, who is from Mumbai, and I have something in common with our hometowns. They have the Elephanta Caves. We have a bridge. It's a nice bridge. It's the first cast-iron bridge in the world. So there we go. That's me. Also, I wrote a book once. If anyone's interested, apparently this QR code will get you a free month on the O'Reilly platform. O'Reilly contacted me a couple of years ago and said, would you like to write a book? And being a sucker, I said, yeah, okay, I'll write a book. Why not? 2 years of work later, I have this rather lovely coyote on the front of my book. Do be warned, if you read it, it is very, very silly, because I wrote it and that's the way I write. I mostly wrote it between the hours of midnight and 3 a.m., and so I am so tired, I am firing on pure random. So, let's talk about the functional programming paradigm. That's what this is about. Functional programming is not a language, nor an add-on package, nor anything of that sort. It is a paradigm. So, what is a paradigm? Well, let's think about guitars for a moment. This is Kurt Cobain playing an acoustic guitar. This is Taylor Swift playing an acoustic guitar. This is Shania Twain playing an acoustic guitar. This is Jimmy Page playing an acoustic guitar. All 4 of these musicians are playing the exact same instrument, not the exact same, but you get the idea, and all of them produce wildly different styles of music. And that's what a paradigm is like. It is not an add-on, it is not a NuGet package, it's not a language, it is a style of programming. The best description of these sorts of things I heard was that a paradigm, a style of programming, is defined by what you are not permitted to do. There's all sorts of things that you can do in other languages that a pure object-oriented language doesn't permit you. Well, a lot of those are allowed in functional programming, but there's a whole load of other things we don't allow you to do. It's a sort of vow of purity on certain things. And that's how we define a programming paradigm. Now, C# supports OOP, that is object-oriented programming, and functional programming nearly equally. And that's not a coincidence. That's a stated intention by the C# development team. They intended it to be a hybrid language. They intended it to support both. And pretty much every version of C#, going from C#3 all the way to at least C#11, have consistently included more stuff to do with the functional paradigm every time. The only one I'm aware of, the recent years that has it, is 12, which I don't think really had anything. But that's not because they've run out of ideas or because they're done. They just didn't have anything that time. And probably C#13 or at latest C#14 is going to have some more stuff. I know for a fact that there is more that they're working on, but we'll have to see what comes out when it comes out. So, there are families of paradigms, okay? The two main ones, there are others, are imperative and declarative. Imperative programming is what most of you are probably familiar with from the beginning of when you've started developing. Imperative programming is based on the premise that, kind of like the way you might describe it to kids, there's kind of like a little robot, and you're telling your robot where to go in the code. You're saying, start over here, go here, go here, and go here. There's an if statement, go that way or that way. Oh, I'll go this way. Here's a loop. I'll just run around in a little loop for a while, and I'll carry on. That's imperative style coding. Object-oriented programming is a form of imperative, and in its purest form works by something like instantiate a new object and then start populating it, use ifs and fors and all the rest of it to work out how you create each of those properties, then add them into the class. That's an object-oriented approach. Declarative doesn't work like that. Declarative works more by describing what you want and then leaving a lot of the detail of order of executions and how things are assembled to the compiler or to the execution environment or whatever. Now, that might seem like absolute heresy, but I almost guarantee that all or most of you here will have already done declarative programming already. The most common form of declarative programming in the whole world is SQL. SQL is declarative programming. So, functional is a form of declarative. Consequently, it is very different to imperative paradigms like object-oriented, but it's not necessarily all that easy to get into. So what are the basic concepts of OOP? We've got abstraction, encapsulation, inheritance, and polymorphism. I am hoping that you are all familiar with these because you won't need to know anything about them whatsoever for the purposes of this talk. Functional programming, on the other hand, immutability, predictable side effects, free functions, functions over statements, and stateless. Okay, there is a common myth that functional programming is hard to understand. It's not. In fact, there are fewer things to learn in functional programming compared to object-oriented programming, and they're not as hard, generally speaking. If you do not believe me, then as a challenge, try this. Go and find a non-technical member of your family and then try to explain polymorphism to them. Try. And I almost guarantee that their eyes will glaze over because no one except for weirdos like us really need to know what that is. And yeah, I could do polymorphism pretty easily. I don't really even think about it very much, but I've been doing this for 20 years. If at my point I didn't understand it, something's gone wrong somewhere. But I can remember going back to my university days where I struggled to understand what the snot that was all about. But picking up functional concepts, so long as you're prepared to kind of take your OOP brain and park it and put it in a box somewhere, isn't necessarily all that hard. Now, I'm going to talk about a load of these concepts now, and hopefully you'll get the idea of how this all works. So, the other thing I'd like to mention is, why is it called functional programming? One of the smallest hills in the world that I will nevertheless die on is that functional programming is an absolutely diabolically terrible name for it. Functional programming? This means nothing to me. What is all other programming? Is it non-functional code? Well, no, that's not what it means, but yes, it's not very intuitive to pick up. Object-oriented programming pretty much spells out what it is. Functional does, but it's misleading. Functional programming is called this because it's predicated on the idea of functions composed together like Lego bricks, with each function being a Lego brick, and then you assemble these function Lego bricks together to make large, more complex functions based on tons of little ones. That's why it's called functional programming. And there is a rule of thumb in functional programming. If there is a question, the answer is functions. So, what are the advantages of functional programming? For one, it's easier to maintain. This is for several reasons. For one, it's a lot easier to read. Once you've gotten into how it works and how it's structured and what all the terminology is, it's far easier to read than the object-oriented alternative. The length of functional programs tends to be considerably shorter compared to OOP. There is less what you might call code noise. So this is what I call it. So in audio engineering, there is a concept called the signal-to-noise ratio. The signal is the thing you wish to listen to. The noise is something that comes along with it that is not wished to be listened to. So if you are listening to a cassette, and I'm not sure why you would in these days, but if you were, then the signal is the album you wish to listen to, the noise is the hiss that comes along with a cassette. If you were listening to a record, then the noise is the rumble that comes along with the record. If it is a Justin Bieber album, it is the album itself. Now, in code, when I talk about code noise, the signal in code, to me, is the business logic. It's the thing you are trying to do. It's the thing that this code does. If you tried to explain the purpose of this code to a non-technical member of staff, your boss or whoever, then the signal is what this code does on a logical level that can be comprehended by a human being. The noise is all the other stuff you have to write to make it happen. All the other stuff that's just sort of connective tissue of code. Functional has significantly less of that, where imperative code is filled with it. So it also is easy to maintain because the nature of functional enforces good code structure. You're almost forced to write things in a more reasonable, logical manner because everything tends to break down by logical steps. It enforces things like writing small composable functions, which tend to be easier to maintain in the long run for various reasons. For one, they don't expand and get out of control and end up thousands of lines long. I have worked places where that was exactly what happened, and those functions become nearly impossible to maintain after a certain amount of time. Another is that with enforcing composability of functions, you're also encouraging reusability of functions. Reusing the same little micro function many times again, which has already been used in production and is already tested and known to be good, means that you are generally getting a better quality of code with the more enhancements that you do. And code spends the vast majority of its life in maintenance phase. You've got the initial development phase, which might take a long time. It might be months, it might be a year. That's quite long, but that is nothing compared to the length of the entire life of the project. The entire life of the project could be 20 years or more, where it's living in production and being enhanced regularly. Functional tends to make it very easy to live with the code once it's in production. It's more robust. It fails less. A pure functional language often claims that it never fails. That could be Elm and Erlang and Haskell and stuff like that. Supposedly, once you've got that thing to compile, nothing will kill it. Could be, could very well be. I am a C# developer. We can't quite achieve that, but we can get pretty close. We can get pretty close to errors not occurring in production anymore, which is a pretty good goal to aim for. And it's more testable. It's far easier to write unit tests. It doesn't use state exactly as a concept. So it tends to be easier to write unit tests that don't require a lot of setup. And the functions are written in such a way that the actual results coming back are easier to interpret in a test scenario. So fundamentally, it's better code. Disadvantages. It does mean learning a bit. Now, I don't know about all of you folks. I quite like doing a bit of the old learning. I mean, that's the sort of thing I do for fun. When I'm not doing this, I'm usually picking up new yarn craft skills or learning to paint or learning a new language or anything like that. I love learning. So to me, this is not a bad thing. This is actually a feature, not a bug. But your mileage may vary. Can be suboptimal performance. I want to comment on this. This is another common criticism you hear around. Can be suboptimal performance. Functional programming is slower. Right, let me address this. It's sort of true, and it also sort of doesn't matter. Okay, so more often than not, in the vast majority of cases, the difference in speed between functional and non-functional, in the majority of cases, is like going from about this much of time to about this much of time. But throw in a web API call, and it's like going from this to this. It's insignificant in the majority of cases. And there's one or two where things may be to be considered. But even that aside, all of the advantages are so significant with functional that I would argue it is absolutely worth any trade-off within reason. Because if you want a comparison between the sorts of things these programs are doing, then something like pure imperative is like this guy zooming along fast as you like. And if speed of execution is your only concern, then to be honest, even object-oriented C# is probably not good enough for you. And you want to start thinking about stripping away the type safety and writing your own absolutely from raw parsers that process everything, including like bit shifting things around and messing with binary and all these sorts of things that make your code illegible but incredibly fast. But the disadvantage of someone like Tom here, who runs so incredibly fast, is all you have to do is stick your leg out and it'll trip over. Code of that sort fails easily. Whereas, see, that's what happens. Whereas functional is more like this guy. So functional might not be the fastest. Now, okay, it's not entirely a fair comparison. I mean, although we did, don't they say in the film that they clocked this guy running at about 40 miles an hour or something like that? That's pretty good. But the point is that he's a great, big, lumbering dinosaur. The interest is not in making it fast. The interest is in making it unstoppable. The interest is if you want your code to go into production and then go up and stay up and not fail with all sorts of awfuls, then functional is a far better solution, and the trade-offs are 100% worth it. If, on the other hand, you're writing a VR application which has 2 high-definition streams, one into each eye, you probably want to strip away every last little bit of protection and everything that you can just to emphasize speed. But I'm willing to bet the vast majority, or possibly even all of you here, don't work in such an environment. Most of us make business applications that are going to go and sit on a server somewhere and serve a whole, a few hundred users at a time or something like that. And it is far cheaper to go onto Azure, onto AWS or whatever, and press a button, which means that you've now bought an extra RAM chip for your virtual machine, and then let that speed things up, than it is to pay a developer to have to go and look at object-oriented code that's just so horrible to work with that it takes days of your time to get anything useful done. We're expensive. I mean, not to blow our own trumpets, but we are. We cost a lot of money. So it's much easier if our development time is quick and easy and can be done without too much effort. Plus, it makes us happier too. So let's talk about immutability. Immutability. What is this? Immutability. This is the idea that all variables are read-only and all of their properties are read-only. Everything is read-only. Once you have instantiated something, you can't change it. All of its properties cannot be changed. Everything in the entire code base is read-only once instantiated. Okay? I'll try my best to give an example of why this is such a powerful idea. Now, this is an absolutely stupid bit of code I threw together just to give a little bit of an idea of something. So I am a massive fan of Doctor Who. It is, if you look in the dictionary, the best TV series in the entire world. And it didn't even have a rubbish ending like Game of Thrones, in that it hasn't ended, it's been running since 1963, and it's still going just fine, thank you. So, in this imaginary scenario, which I've modeled after an episode of Doctor Who, because why not? Because I don't want to get bogged down in real-world logic. I've instantiated a main character for my TV program. I've given him a number. I've given him an actor's name. It's William Hartnell, the boss himself, the first guy from 1963. We're going to do some stuff, whatever my business logic is for the rest of my application, and then I'm going to print the actor's name at the end. Okay. Seems fairly straightforward, doesn't it? So what comes out of the console? Humphrey Bogart is what comes out of the console. How did that happen? I instantiated it. It said William Hartnell, but then I did some stuff and I passed him in to these functions and it came out and it said Humphrey Bogart. What's he doing in there? What's happened? Okay. Well, inside one of those functions, it changes the actor's name. This is a silly example, but I have seen real-world stuff like this. What's happened is that the class is passed by reference. It's passed by reference, meaning that inside the function that consumes that class, any modification to that class will modify it in the outside world too. This is incredibly dangerous. This is like loaning your book to your friend and hoping they're not going to bend the pages and bend the spine and drop ink on it and whatever. It's a dangerous and worrying scenario, and it's the sort of thing I don't like. I have worked in places where this was used and abused in something like the following manner. So, okay, I've made one function that modified William Hartnell into Humphrey Bogart. Well, that's not too challenging to work and fix. What if it was in a sub-function of that original function, or a sub-sub-function, or a sub-sub-sub-function? I might be getting a complaint from the users saying William Hartnell keeps turning into Humphrey Bogart, and I have to go trawling through the code base trying to find the place where this change is happening. The actual scenario that I encountered was worse than this, because it wasn't one big code base. In fact, we had a code base which was huge, which was underpinned by a DLL library, which was huge, which was underpinned by another DLL library, which was huge, which was supported by a gigantic set of stored procedures in SQL. That is a real scenario that I had to live with. And so when someone said that box is changing its value and we don't understand why, it could literally take days of time to work out why. And it could be worse. What if the rule is split in 3 places? What if there's a scenario that requires 3 particular circumstances to all line up just so, and only then will you become Humphrey Bogart? You laugh, but that is the sort of thing I had to deal with. The company that I dealt with back in those days was international and had clients and customers all over the world, and they had to follow international regulations for each country they dealt with. And so they had huge, great if statements that said things like, if it is Brazil or Sweden or Mexico, then, and inside that you'd have an exception which said, but if it's Sweden or Mexico, and inside that you'd have another exception which said, but, and so on. And so the business would say things like, there are 3 rules that populate this box. We want to make a 4th rule, and then I'd have to go traipsing around trying to work out where the first 3 rules even are, and they could be anywhere. But if you flick all of this around, if you make it so that everything's much more straightforward and these sorts of modifications don't happen, then life becomes so much more simple. This is mathematical working. This is what functional programming is modeled after. Now, functional programming is actually really old. It predates object-oriented by decades at least. The ultimate origins of functional programming are mathematics papers from the late 1800s. But it is modeled after the style of mathematics. And this is maths. So this is a maths working. This is the process for working out the hypotenuse of a triangle. That is the big, long edge of the triangle. Now, what's interesting to note here is these are definitions. These aren't variables, not like we think of them in the object-oriented world. These are definitions. The definition of A is 10. The definition of B is 15. The definition of X is a function with 2 parameters, which returns the square root of the 2 things squared and added together. Those are each line-by-line definitions, which means that if the answer is wrong at the end, you can go back over the working and you can work out where it went wrong relatively easily. In the UK, when I took my maths exams, you get part marks for showing your working so they could work out what went wrong, because it's easy. When you work with definitions like this, all of the previous states still exists. And this is how you might write that in C#, for example. It's not any real effort to start writing this way, but I'm thinking, I mean, you wouldn't literally write A is 10, but I'm just keeping things simple here. But you could write it this way. Make each line a definition of a concept rather than being a variable which could be updated and reused. So how would I fix this slightly imaginary scenario? I might do something like this, for example. Make an explicit dress as Humphrey Bogart function which takes the object, which is the actor on the top level, and then returns a new one based on the old one, which means that nothing has actually been modified in the outside world. The outside world can trust that everything is as it was, and it's easier to work with. Has anybody ever worked with Redux, React Redux? Yeah, a few of you. This is a functional programming-based library, and that's exactly how that works. That's how state management works in a functional world. You don't have a state object which can be updated. Instead, what you have is a series of state objects. Whenever you want to update state, you take the old state object, some parameters, and some instruction, and then you, from those, generate a new state object, and that becomes the current state. But you never modify or delete the old one. That is why in things like React, you can do that time travel thing where you can just go back in time because all of the previous state objects still exist. Could even go a bit further and just sort of make it more generic like that and take a string, but there we go. So that I might rewrite it, for example, something like this. I've now got a separate object, which is the disguised version that looks like Humphrey Bogart, and at the end, I have the original untouched and the modified one, and I can even reference them both. How about something like this? This is a sort of more real-worldy example, calculate a price. I might get a part, find its basic price, calculate VAT, calculate markup, and so on. And in an object-oriented world, you might do something like this, where you're modifying the price each time. But in a functional world, you can't do that. You can't change anything. So we might do something like this, where each line is a definition based on the old one with a modification. But what that means is you can put a breakpoint on the line that says return price with markup. You can put a breakpoint there, and every single bit of the working that led up to that point is still in existence and can be examined. You don't need to step through, examine, step through, examine. It's so much easier to work with. It's simple. And if any of those numbers are wrong, you'll be able to see in a glance which number has gone wrong, and then you can start drilling further down into why that happened. So, a challenge for you all, at the very least, to take this idea forward. Treat absolutely everything in your entire code base as read-only. Have no void functions in your code, because a void return type on a function means it's not returning a value, which means it is doing something. And whatever it's doing is guaranteed not to be functional. In the functional world, all functions return a value. Now, I know there's always going to be some exceptions like logging and so on, but that's fine. You can make the odd exception, but give it a go. And you'd be surprised just how much better it honestly makes your code base. But, you know, if you do need to do the odd bit of mutability, then you do, because sometimes out on the fringes of the system there's the odd bit. But by and large, most of your code base can be modified this way. Thank you, Elsa. So let's talk about results-oriented architecture. I've kind of hinted at this before. So object-oriented programming is based on this idea that you kind of start with nothing and build it up, bit by bit, plug bits into it. Kind of like the sort of principle of building a car. You start off with a frame and you stick wheels on it and you stick this on it. And that's an object-oriented way of working. Functional starts with the results. As I said before, this is an SQL statement. I made this up very slightly, but nevertheless, it's a perfectly valid SQL statement. Now, what is the order of execution in this? It's this. It's the from, then the on in the left, then the where, then the group by, then the having, then we're going to go back up to the select and do the select, and then we're going to go back down and do the order by. It's jumping backwards and forwards and backwards and forwards, and it doesn't matter. None of us, I don't imagine, ever really care about that. But look at the way that it starts with a description of what you want. What you want is the top 10 name and count out of the database table. Now, where has this come from? Well, that's on the next line. This comes from employees. But employees has something else. Where did it get? And so on. You're starting with what you want, and then each level is giving you a little more information about where that came from if you need to drill down. That's a very typically declarative way of working. Think of it this way as well. So this is me building a very complex custom object based entirely on some nonsense. But the idea is that I've got 4 properties, A, B, C, and D. And there's branching logic that is based on the day of the week in this arbitrary case, which means there are 2 different places that C is given a value and 2 different places where D is given a value. But what if I start making that more complicated? Now, there are 4 places where C gets a value, 4 places where D gets a value. If the business now want me to modify the logic of C and D, there's an awful lot of places I've got to look at and decide whether I need to go even more exponentially complicated each time we do this. But if you turn this all on its head, you could write it this way instead, which is so much easier. You have only a single definition of C and a single definition of D. flick it on its head. Focus on what you want and define what you want, and then after that, we'll go into the detail if we need it. Now, these are fairly simple bits of logic, because, you know, I made this up. And what if it's really complicated? What if the logic for C is incredibly complicated? Well, for those sort of things, just decompose it into sub-functions. The moment it gets more complicated than a single liner to be able to do it, decompose it. Make a local function, make another private function within the class, put it in there. The moment that gets more complicated than a line or two, decompose that. Keep your function small, single purpose. The ultimate version of the, the drive principle, don't repeat yourself. You know, kind of keep those ideas in your mind. Keep it everything, small, simple, composable, reusable. And again, you'll end up with a much better code base. You see, functional code is like ogres and onions. It has layers. You start on the top layer. The top layer is the most logical, least detailed layer. It defines at the very highest level what you want. And if something's not working, if you need to understand more, you go a level deeper. And that will define how that was built or how that was constructed. And then maybe the complexity of that is such that you need to go another level deeper and another, and so on. Think of it that way. Object-oriented people I know that could play and say, well, I don't know how this was constructed. I don't know where that came from because I can't see all of the loops and the ifs and the branches. And I think it's perfectly fine to work this way. Work by the idea that just give as much information as someone needs at this point. If they need to know more, let them drill in. If they don't, just trust the name of the function to be doing what it says it's doing. There's nothing wrong with that. Code is large and complicated, and our jobs are relatively stressful and not in any way featuring enough cups of coffee to keep us going through the day. So we don't need to keep all that information in our head in one go. The code can document itself by being simple and easy to read. So, predictable code with no side effects. Also called a pure function. This is an important concept in the functional world. That is, all functions should be written with the two following rules in mind. Excuse me. That any function, given the same values in, should always give the same result back. Always. No exceptions. And there shouldn't be any side effects. Nothing else should happen. Functional code is predicated on the idea of removing side effects from your code so that it only does what it says. A pure function takes in some data, crunches it up, and then returns that data, some new data. And that's it. And the more that you can write your code base that way, the better your code will be. So these are examples of some fairly pure functions. Add with A and B, it returns A plus B. If I give that a 10 and a 20, it's always going to return 30. There's no other way to make that work. That's pure. There is nothing you can do with ints that's ever going to make that break. The default value of an int is 0. So there's no way to break that code. That's the ultimate example of a pure function. The say hello there, it does deal with a string, but I've got the null check built in, so that shouldn't be any sort of a problem either to work with. I've handled the null, because throwing an exception is a form of side effect. Because when an exception is thrown, it is the code equivalent of taking a ball and just chucking it in the air without looking at where it's going to go. It's going to go somewhere, I don't know where. And that's a side effect that can be dangerous. I've seen very complex bugs emerging from systems because an error occurred, the pointer, the sort of programming execution needle jumped somewhere else, but it jumped somewhere else on the assumption that other functions had completed when they hadn't because they threw an exception. It's a dangerous business, allowing the order of execution to change because you can't predict the sorts of problems you'll get. Some examples of non-pure functions, just some simple ones. I've only got 40 minutes, really. So add there. Every single time, it adds A plus B and adds it to total and then returns the new total. So it'll be different every time you run it. That's not pure. The say hello there, it's using a property which is attached to the class, and we can't say what the heck that is. So that will potentially be different every single time we execute, not pure. Now, I did used to think that there would be potential null exception there, but it turns out that C# automatically converts null strings into empty strings. That's handy, actually. I like that. Very good, very good. And in the third one, datetime.now, literally different every time you run it. So these are impure. I would refactor all of these into something a little bit better. I mean, the add I just changed to a normal add. The say hello would probably take the parameter, the name it needs, and then just return it assembled. And the last time would probably take a datetime and then add that in rather than calling datetime.now. When I work, I often make an interface which wraps around away datetime.now, so even in unit tests, I can make it predictable. So that's talking about robustness, because it tends to fail an awful lot less. Because this sort of thing makes it easier to test. It makes it easier to test because the effects are predictable. It's always going to turn the same result. It's always going to do the same thing if you give it the same values. Easy to write tests, simple tests. It's not going to give you any side effects. You don't have to worry about capturing things like exceptions, about capturing all the other side effects and then verifying that they happened. You'd fundamentally write the code in a slightly different order to have those side effects happen somewhere else, where either they're outside the scope of the test or just captured in a slightly different way. So it means you can get your code, your unit test level really up to 90% plus without too much effort. So another section, functions, not statements. This is another concept we work with. What is a function? What is a statement? A function is something which returns a value. A statement does not. So if, for each, for, while, and do while. These are the most common statements. There are others, but in C#. All of these are statements. We do not use these in functional programming, not in pure functional programming. Now, C# is a hybrid environment, so you're going to have to use them here and there once in a while, but in a pure functional environment, you don't use them at all. So what do we do instead? Ifs. How do we handle ifs? Chains of ifs? Well, that's pretty easy. Switch expressions. Switch expressions pretty much handle just about every scenario you could possibly imagine for ifs. And especially these days, as of the most recent versions of C#, switch expressions are incredibly and ridiculously powerful. And this is because of functional. Switch expression is actually an implementation of a functional pattern called pattern matching. F# does this, and it's in part because of F# that we have it in C# too. The F#, which is the functional language in .NET, and C# and VB.NET, if anyone still uses that, compile to the same intermediate language. And so because they all compile to the same intermediate language, they need all the same features available to them. So there are a lot of cases where the F# folks have requested something, and C# got it too, because it's in the intermediate language now. And also, it is an intention to become more and more functional with time. So pattern matching or switch expressions, which is what we call them in C#, is an example of this. And these have only become more and more powerful with each iteration of C# for quite a while now. You can do things now like switch on subproperties using this lovely JSON-like syntax. You can switch on types. If you have a parent type, you can switch on which child type it is and have it auto-wrapped into a local variable with the correct typing. As of the most recent update to this, you could match on what are the values inside an array. And I can't think of many examples where I'd ever use that, but I'm just so looking forward to the day when I finally get to. I'd imagine things like file parsing and stuff like that, where you've got binary files with particular file headers. You could literally just switch on this header exists and give the values of the header, and then the function called after that will be the parser for that particular section. This is really good stuff. There's just about no excuse anymore for needing an if statement because this does it. And the beautiful thing about this is, with a switch expression, it encourages you just to keep it one line. Everything the other side of the arrow really best kept as one line. And if your logic is more complicated than one line, subfunction. See? That's the sort of way that we work in functional programming. Decompose everything, split it down, make smaller functions, stick them together. But what if we wanted to parse two values? What if you had a logic that required two values to be compared simultaneously? You can't do that in a switch expression, but you can. Just stick it in a tuple. A tuple is a quick little throwaway object, so just take those two objects, pop them in a tuple, switch on the tuple, bang, jobs are good. Now, tuples are also a functional concept. How about that? It's almost like they foresaw this scenario and gave us something to work with. Converting an array, I mean, this is basically, we don't need for eaches. I'm not even sure why anyone's writing for eaches anymore, because you can do all of that with LINQ. LINQ has been there since C#3, and it pretty much replaces every single for each that you may have ever written. This is simple examples of array to array. We use a select. You can also filter and all the rest of it. You probably know all of these things. You can use sum or something like that to collapse a whole array of objects into a single object. That's called aggregation. So this replaces pretty much any use of a for each. There is also a slightly more complicated one. Now, I don't want to go too much detail here and now because I'm just trying to keep fairly high level, but there is a function which nearly no one seems to know about built into LINQ called aggregate, in which you can supply complex logic for reducing a whole array of items into one single item, which is built up an iteration at a time by passing an arrow function in, which is iterated against each item and tells it how to update state each time it executes. It seems to be one of the most weirdly well-kept secrets in the whole of LINQ, and yet it's been there since C#3. And I use it all the time, because it pretty much does everything I need if a straight-up select statement doesn't do what I need. So what if I needed to compare two arrays side by side? Well, you can't do that with a for each. No, you'd need a for loop. That's true. So this is imagining I've got two arrays, and I need to go to each 0 position in the 2 and compare them, each 1 position in the 2, compare them, each 2 position, and so on, side by side, the two arrays. Can you do that in LINQ? Well, yeah, well, it's in my slides. What do you think? Of course you can. Zip. Has anyone ever come across zip before? Oh, it's actually quite impressive. I only discovered it myself a couple of years ago. It's pretty cool. What zip does is take two arrays and lay them side by side. Each 0th position element, side by side, but it gives you back as a new enumerable, which has got two properties. One's called first, the other's called second. First represents one of the array, one element out of one of the arrays, and second represents the corresponding element of the other array. So you're literally seeing the two arrays zipped together like a zip, where the teeth mesh as it goes along. And that's what that does. So that's great. What if I wanted to find something like the diffs? What if I wanted to compare consecutive elements of the same array? That is, compare each element to the one before it, so that I need I and I minus 1. Can you do that with LINQ? Yes, you can. Yes, you can. It's zip to the rescue once again. What you do is you take the array, you skip 1. So skip 1 means take that array, make a replica of it with the first item missing, then zip this new array with the item missing against the original, and what you've got is the same array being referenced twice, but shifted one place, and allows you to compare consecutive elements in LINQ. So no, I would argue there is no scenario in C# where you need a for or a for each. But wait, what if you actually do need I because it's part of the return value? What if you need I to actually go in there? Well, there's actually two ways of dealing with this. One, there's an overload in a select which actually gives you access to I. It's hidden there. Alternatively, if you need it to be something other than 0-based, enumerable.range. Enumerable.range will generate an array which starts at the position, a value that you say, in this case 1, and then will carry on incrementing by 1 in each element up until the number of elements that you need. So in this case, if, for example, my source array had 5 elements in it, this is going to create an array of integers with the values 1, 2, 3, 4, 5. And then you zip it and select it and so on, do whatever you want with it. But enumerable.range and then select is quite often the way that I add that sort of I value in. And doing it as enumerable.range is far more intuitive in some ways because you don't have to worry about 0-based, 1-based, and all that sort of thing, and having to add in the extra pluses, 1s, minus 1s as appropriate throughout. It's intuitive. It is the number that you want generated. Wait. What about while loops? Now, this is a bit of a sore point, in all honesty. So all the loops I showed you so far were what's called definite loops. By definite loops, I mean they loop a definite number of times. It's going to start at 0 and loop to 10. It's going to start at position 0 and go on to position length -1, and so on. That's definite. I know how many times, or sort of. I know it's a little bit more complicated with enumerables, but roughly speaking, I know how many times. But a while loop carries on and carries on until a certain condition is met. Now, there is not a functional way of doing this that isn't painful or ugly. Those are your choices, painful or ugly, and that's it. I'll show you what I mean. The classic example is recursion. Recursion is your classic method in functional languages of dealing with these sorts of unbounded loops. The problem is that in C#, recursion is not safe, by which I mean if you recurse too many times, then you will get a Stack Overflow exception, and that's the way it is. F# won't do that, interestingly enough. F# has safe recursion. So if you have a massive recursive function, it will actually fix it for you in the intermediate language so that it's safe and you don't need to worry about Stack Overflow. Now, how does it do that? Well, I had to crack into the IL. What it does is replaces it with a for loop, a while loop. It replaces it with a while loop. It's not exactly a while loop. It looks a little funky, and there's a whole load of low-level commands, but that's what it is. So the other method, and the one I tend to favor, is called trampolining, for reasons that I do not know. But this is what it is called, nevertheless, trampolining. Maybe it's based on the idea that each iteration is like bouncing on the trampoline, and I don't know. But that's what it's called. An example of trampolining. So if I were to create this rather silly example of adding with my while, which is just adding 1 until a particular value is met, which is a thing I'd never do in production, but keeping it simple. Trampolining might look like this. A do-while function, which takes 2 function parameters, that is arrow functions. One is to define the conditions for continuing the loop. The other is the transformation that must occur in each iteration. And so it will keep running the transformation function and then checking against the condition function until the condition says it's time to stop. That's trampolining. Now, how does that work behind the scenes? It's a hidden while loop, because that is the only way to do it. Now, I do stuff like this in my code. This is where I say do as you will, because there are no rules and it's all fine, and C# is a hybrid language at the end of the day. This means, though, that I have written one while loop, and that is probably the only while loop I will ever write in my entire code base. I am at peace with this. And if one day Microsoft decide to introduce some better method, I can always replace this method, point to whatever the new thing is, and then even that while loop is eliminated. And that's fine. If you decide it just doesn't matter to you, use a while loop. It's all right. I won't tell. There's no standards authority for this stuff. Goodness knows we could do with one. There's absolutely no standards in naming conventions in the functional world. You'll hear everything called about 4 different names in 4 different languages. Aggregate is actually a C# implementation of a thing which is normally called fold or reduce. But we called it aggregate for reasons best known to Microsoft. So it's your choice. If it is if you're happy with the do while, do the do while. If it's really irritating you that there's still a while loop in your code, you need to be using F# at this point, because C# is clearly not going to satisfy you. Project structure. So I'm just going to talk on this briefly. This is a design pattern that's come out of the functional world for languages like C#, and it's called imperative shell functional core, or the other way around. You get the idea. The idea is that on the outside perimeters of our system, we have side effects happening. Side effects that can't be avoided. We write our code based on the idea of trying to minimize and eliminate and reduce side effects, but in these cases, database connections, web API calls, dirty users, all the rest of it, we literally can't avoid those side effects. They're going to happen. Even a file on the local file system could become unavailable for any number of reasons, and that is a side effect. So What you do is you allow all of the classes on the edges of the system are allowed to a bit of imperative error handling and so on. But what they then have to do is once they've handled all of that stuff, you put it into a data structure which is functional and then pass it into the inner parts of the system, the business logic layers and all the rest of that, that is pure functional. And that means it's kind of like an airlock. Think of it as a sort of like an airlock on a submarine where the outside world of water is imperative and dangerous and full of motion in motion, as they say in 20,000 Leagues Under the Sea. And that is then, you have a safe environment inside the airlock where you can close both doors, make sure it's safe, and then open the inner door to be pure functional or dry in the case of a submarine. I go a step further with this, and I add a little extra blip in the middle. Because I write, and this is a bit of a C# specific thing, I write extension methods which allow more functional style code to be written in the rest of my code base. And so I allow imperative code inside those extension methods, so long as it doesn't leak out anywhere else. But if you follow this design pattern, I guarantee you'll get a really good, robust code base. So ways of handling side effects. There's the main one in the functional world looks something like this. So this is a cat in a box. So there was a thought experiment, which I don't entirely pretend to understand. And it was developed by a man called Erwin Schrödinger. And if you ever see a picture of him, by the way, he looks like his name is Erwin Schrödinger. And it was a satire of quantum mechanics. And it goes something like this. You've got this, you've got a box, you pop a cat inside it, and there's a radioactive isotope, which has a 50-50 probability of decaying or not decaying. And if it decays, it kills the cat. If it doesn't decay, the cat is alive, but presumably not impressed. And according to quantum mechanics, until you open the box to look, the cat is in both states and neither state. It is alive and dead at the same time, and also neither. So fine. What it means is that if you want to know what's inside the box, you open it, and either you find a dead cat or you find an angry cat. Either way, it is bad for us. But if you don't care, if you are more sensible and want someone else to deal with the angry ball of fluff that's likely to come out of this thing, then you just leave it as box and pass the box around from place to place until someone cares enough to open it. That's Schrödinger's cat. So in the development world, our two scenarios are everything went absolutely fine with the operation that you attempted, or it didn't. Those are our two quantum states. Every operation that touches the outside world exists in these quantum states. It worked, or some sort of exception beyond our control occurred. Two quantum states. And it might look something like this. A result is one way of describing it. Result is success or failure. Success means data came out. Failure means error came out. And that's how I might implement it in C#. Now, this is something kind of called a discriminated union. A discriminated union is a type which is one of these two types, and I don't know which one until you look. It's a box. It's a box with a label on saying it's either success or fail, don't know, it's one of them. And until you look, you don't know. I've implemented it here with an interface. In a real functional world, you don't need the interface. You would just say that result is success or fail. If anyone's ever used TypeScript, you've seen this stuff, union types. F#'s got them, a whole load of other languages have got them too. C# doesn't. There are libraries that you can install which will allow you to do this stuff. One of is a famous one. And I keep being told that union types are coming, but I don't know when. They're coming at some point. And apparently the problems are design problems. I don't really understand it, but cleverer people than me have said that it's a difficult problem to solve without ruining backwards compatibility and killing every C# app ever written. So fair enough, but it's coming. And how I might generate that is something like this. Let's do our data sort of getty do a thingy. I don't know what that would be. It's a database lookup. It's a web API call. It's a something. Do a try, do a catch. If it's a catch, then I'll return a new error. If it's a success, then I'll return a new success. And I'm using a generic so that my success and fail can contain whichever data item I want. And then at the end, you might decompose it into a single thing like this. Bear in mind, this is now two quantum states. Result contains nothing. There's nothing in result. It's really just a wrapper to say it's one of these two types, success or fail. So you pass it around as result, well, it doesn't matter. And then when it does matter, you take the two quantum states and supply the transformation that map each of them into the same thing. In my case, a string. Success or fail, they have to become a string. This might be at the point of sending a message to the end user, or this might also be something like an action result in a controller or something like that, which will decide which page to direct you to, error page or data page. And it might look, as you pass it around, something like this. You start with the web API call, you split into the two quantum states, success and failure. You pop them into an envelope called result. There are various functions that act on the result by sort of opening it up, having a look, doing something, closing it back up again, and so on, blah, 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 like that. And then at the end of it, in the MVC layer, you've got yourself a result, at which point they open it and then decide either to redirect you to a view or an error page. That's a functional way of handling error. And there is a process where if you need to change from, say, a result of string, containing a string, and then change it to a different something else, some sort of complex object, then you have to work out something done by following these paths. It's either it's a failure, in which case you'll just leave it as a failure in the new type. So map failure of result of string to failure of something else. Otherwise, if it was a success, then you take the old value out of the box, do a transformation, pop it back in the box again, and then you pop it on. So we've gone from two quantum states here, mapped to two quantum states in the new result envelope. So, and I do it with a function there, if you can see there, called bind. Bind is a function which basically takes a function as a parameter. The function is the transformation of the old value into the new value. And inside bind, there is logic which says, was that a failure? If that was a failure, just take the error message out of it and pop it along. If that was a success, take the successful data item out of it, run it through this function they provided me, and then pass it along again, which means that you can write the function I pass into the bind here, assuming that there is no such worry as a null value or an exception. Those don't exist anymore because bind copes with all of that for you. This is an example of what it might look like. And we can make this more and more complicated to make this safer. You can do a null check against the old value to make sure it doesn't fail. You can do a try-catch around this, and if an exception happens, then we'll switch to a failure. And it means that every single call to bind then would have a null check and a try-catch built in, and you can use them in complete safety. So, and then you can even do chains of them. Chains of things like execute these various stored procedures, and every time it will only execute as many as succeeded. If stored procedure 2 here failed, it knows not to execute the third one because a failure is returned from stored procedure 2, which means it's not safe to execute stored procedure 3. So one chain of functions, and all of that switching logic is built in. This is just about something we call a monad. Now, in case anyone ever wondered what one is, this is kind of what one is. There's a little more to it, and I'm not going to go into that here. This is kind of technically a functor, but no one cares. I don't. Right, last section, domain modeling, and then you can all go and have some food. Another way to think about discriminated unions is domain modeling. So this is a completely arbitrary, hypothetical way of rendering a Western-style name. This is Mr. Benedict Timothy Carlton Cumberbatch. What a name. It's almost like he's posh or something. So his name's fairly easy for me to render in this data structure. He has a title. It is Mr., as it happens. There's not many titles, Mr., Mrs., Ms. There are a few others. We've got a first name. We have an enumerable of middle names because you can have between 0 and many. I have one, it's John, and then your last name, and so on. So that's easy. And then we can write a hello function at the bottom to say name, first type name, middle names, if any, otherwise an empty string, and so on and so forth and so forth. Easy peasy. This is Jackie Chan. Jackie Chan is from Hong Kong. Jackie Chan's name is not Jackie Chan. That's the name he goes by because it's easy for us all to call him that, but it is not, in fact, his name. His name is Fang Shilong. Fine. And also the title in Mandarin is Shansheng, which kind of means firstborn or born earlier or something like that. And that's fine, okay. So that seems kind of like you can pop this in here. He doesn't have a middle name, fair enough. But his title is Shansheng, his name is Fang, the last name is Shilong. Except Chinese names aren't written that way. Chinese names are written family name, personal name, title. To correctly write his name, it should in fact be Xilongfang Xiangsheng. It's wrong. So you could mangle this. You could mangle this and put the names in the wrong order, and then you'd also have then to put a flag somewhere that says it's a Chinese name, so you've just got to know to mangle all the data into the wrong order when you do the write out. And also he has a courtesy name. Many people from China have a courtesy name, which is a sort of Western-style name that makes it easy for folks that can't pronounce their Chinese name to use. His is Jackie. And you suppose you could put that as his middle name, but once again, we're just absolutely mangling this data beyond all description. The other way you can do this is by putting it in a discriminated union. A discriminated union called name. Now, once again, I'm simulating it with an interface. In a real functional environment, you wouldn't need that. But I'm saying that there is British name and Chinese name, and they actually have different properties. Properties that are meaningful to each specific logical case. I don't need to worry about putting first name in there when that isn't exactly a useful or meaningful concept to someone from China. Last name, again, not exactly. So we're kind of following a DDD principle of making sure that we're sticking to the language that makes sense at the lowest level, and then union typing them to say it's either a Chinese name or a British name. And those are two examples. There are many, many, many other naming conventions all around the world, and each of them will be different. And then you could put each of them in a union type, and then you could write a function which then just switches based on the real type and then does the correct render underneath that. That's simple. And there's none of this. You just kind of need to know that first name in a Chinese name is not really the first name, it's the last name, and you have to write it last. And that's a mess. But this is simple. This is easy. So that's one of the reasons why discriminated unions is such a desired feature in C# and why it keeps being promised again and again. So, hoping that we're going all right for time and I don't have to excuse you all. I think we're doing fine. Okay, last up. This is it, finishing up. This is my book again, if anyone is interested. I did write it. I do warn you, it is very silly. Yes, you will learn a lot about functional programming, but you will also find out who is my James Bond, my favorite James Bond, and who ordered the pizza. You'll see when you see it. Also, I do workshops these days. If any of your companies want me to do a workshop, I kind of do workshopy things for a couple of days, or I can bore people at length for several days all about this stuff, because I find it all very exciting, and we'll talk about it at length. So thanks, and before we finish, has anybody got any questions before we go? Oh, I saw a hand there first, sir. So how is, apologies, I'm just going to come down for a moment. My hearing is terrible.
How is the very complex link queries are more readable than OOP?
Do I think that complex link queries are more readable than OOP? I would say, like with a lot of things, it depends how you write them. Oh, by the way, since you asked the first question, have a book. I wonder if anyone else will have any questions. So I would say it all depends on how you write. I would always try and decompose things. I think the moment that you've gotten too complicated that it stops being readable is the time you now need to decompose it down into something where each component is readable, and then maybe reference a function in the link query which then contains the additional logic, rather than making your link longer and longer and longer and longer and longer. If it's just a few lines of link, then by all means, leave it like that. If you're having to write your link and it's starting to get this long, then maybe it's time to start decomposing it because you've made it too big. But decompose it in a functional style. To the best extent I can, I write all of my functions so that they can just be straight-up arrow functions in everything all the time. That's how I write them. And keep them small, keep them simple, but keep them simple by decomposing them. Think of layers. Layer of minimum complexity, maximum abstraction, then keep going down a layer as you need to drill into it. And usually, even the most complex link queries can be decomposed that way. I've only got one more book, but right, we've had one from this bank of chairs, and suddenly there's a flood of... Oh, I did see that hand first. I'm sorry. Sorry, everybody else. It's the last one. There are others in the shops. I didn't set the price. Apologies about that. I also have to come over. I meant to do that. Here. What was your question? Why not? Is that... Yeah, okay. Is that still? Yeah, it's still working. Why not use F sharp in the functional bit? Well, there's always one, isn't there? There's always one. Yeah, okay. You can reference F sharp projects inside a solution. C sharp and F sharp can stand alongside each other perfectly happily. So, why not use F sharp fundamentally? Someone always asks me this, and I'm just going to check my exits, because I know what the F sharp guys are like, you monsters. There's nothing wrong with F sharp. There's nothing wrong with F sharp at all. There's nothing wrong with merging F sharp and C sharp. Do it. If you like F sharp, if your team is comfortable with F sharp, do it. Nothing wrong with it. Problem with F sharp is no one uses it. It's a I know that's a self-fulfilling prophecy, and it is a self-fulfilling prophecy, but the reality is, in the pragmatic world of development, no one uses it. That's not entirely true. I know a couple of companies that do, but a lot of the ones I do know are shifting to C sharp after experimenting with F sharp, not because they didn't like it, it's just because they can't get people. It's just the way it is. I'm hoping that balance shifts one day. It would make my heart sing if I saw that F sharp was becoming the latest hot skill to get, but it's not. And that's just the way it is. So my choice of functional C sharp is not based on it being the best tool, but it's a pragmatic business choice based on the availability of developers on the market. That's my reason. But F sharp is a valid choice and probably better for this stuff than C sharp. If anyone wants to dig further into F sharp, I recommend you do so. Does anyone else have any further? Okay, you may need to shout it. Yes, language X. I know it.
But it seems that it's not maintained anymore. So
Okay. Okay, the question was about language X and apparently not maintained anymore. I didn't know that, which is unfortunate because we use it extensively at work. Language X is actually really good and really powerful, and it handles monads in a much better way than my fairly trivial examples here. I don't know if there are any other libraries. I also don't have a problem with rolling my own. As you can see, it works mostly perfectly well. So I don't know on that case. We honestly just use language X. It's really good. And it's very hardcore and very pure functional theory, so it has a heck of a learning curve, but it's worth getting into because it is very powerful. So I don't know, I'm sorry, I don't know of any other libraries. But there are a few, I did review them in the book there, but LanguageX is the most comprehensive. I don't know anything else on that scale. Does anyone else have any further questions? No? Then I wish you all a good... Oh, whoa. Was there someone? Oh, goodness me. I'm really going to go over to you here now. My poor hearing will not survive it.
Okay, so since your approach is to maximize abbreviations or
Yeah, to maximize the sort of functional area. Is the microphone still working while I'm over here?
so
Weird. Okay.
basically, with that many abstractions, how would that affect your sort of file structure?
How would it affect my file structure?
Yeah, would you have a lot of functions to sort of
I think everyone's going. Tell you what, come to me afterwards. We'll have this discussion, but I think everyone's keen to go for lunch. So go on, get the lot of you. Thank you very much.